So in the last lesson, section 1, day 2, we talked about permutations. Today we're going to talk about combinations, where order doesn't matter. A combination is an arrangement of items in which order doesn't matter. So we're no longer saying, well, you'll finish first, second, third. Now we're just saying, okay, well, the top 3 will advance. So it wouldn't matter to me whether I was first or second. I still get to advance in whatever I was doing. Formula for this as well, but again, we'll use the calculator. If you take a look at number 2, there are 8 swimmers in a competition where the top 3 swimmers advance. So it wouldn't matter whether I was first, second, or third, I still get to move on. That's what makes this a combination. 8 people start, but only 3 people get to advance. Use the calculator the same way, start with the 8 and hit the PRB menu. But now we're going to choose the second option because that's a combination. And then 3. And I should get 56. There are 56 ways for that to happen. Mr. Toth calls Mrs. Camp and asks her to send 4 students to the office to carry supplies. How many different groups of 4 students can she send from her class of 21 students? This is a group of 4 students, so it doesn't matter whether she would choose you first, second, third, or fourth. When you walk into the office to carry supplies, your order of which she called you doesn't make a difference. And so this is a combination. There are 21 students in the class, but only 4 of them will carry supplies. So hit 21 first, then the PRB menu, hit the second option, and then 4. 5,985 groups. Again, order doesn't matter. It doesn't matter whether you're called first, second, third, or fourth. You still end up going to the office to carry supplies. This would become a permutation if the problem said where the first person chosen carries pencils, the second one carries books, or whatever. If they assign specific roles, it would turn into a permutation. How many different teams of 11 players can be chosen from a soccer team of 16? So there are 16 people to choose from. This is a combination because those 11 just become one big team. There's no specific role. Nobody's more important than the other. So you're going to do 16, then choose a combination, and 11. You get 4,368 teams. That's what I thought. And again, if I specified and said where the first player chosen was the goalie, and the second player, and the third player, the second I assign roles, the order matters. But right now, because they all make it onto one big giant team, it wouldn't matter who was chosen first. Don't worry about the formula right now. This one would have ended up being an 8C4. This one's going to be a 15C3.